Okay, looks like it's working. I'm going to share my screen. All right. Hopefully everybody can see that. I miss my big green bar around the outside, but I think it's okay. So this is an intro to SaltStack. It's software to automate and document the management and configuration of any infrastructure or application. Being DevOps practitioners, I'm sure you understand the concept of infrastructure as code. This talk was put together originally for the Columbia area Linux users group, and it's been not really modified for this group. So it might be a little bit on the light side from what you're used to, but anyway, it's just better than nothing. So this is what we're doing. I added the end document in here. You notice this is in brackets because really my motivation for using SaltStack is because I hate documentation. And I don't like maintaining documentation, and I don't like sharing documentation with other people so they can criticize it. So that was kind of the big motivation for me to move to infrastructure as code. Let me see something here. Oh, okay. Oh, so who am I? I'm Nick Vissari. My Twitter handle is Nick Adam, and I work at Howard County Public School System, which, as you all know, we're making some serious changes here recently with the coronavirus and working remote. I've been working remote, and we're going to be looking at some distance learning options for our students. And so that's going to be really exciting. It's going to require some changes on our side from IT. So really exciting stuff going on right now. Horrible, but exciting. So I'm a security guy there, and I'm also a DevSecOps enthusiast. So I work with the development team, I work with the operations team, and I am currently a security team of one. And we have some positions open, some new engineers coming in. So that's also exciting. A lot of good changes happening at Howard County. So I have a degree in cybersecurity information assurance. I have my CISP, and I'm a certified cloud security professional. So if you have any questions about that, feel free to hit me up on Twitter. I worked really hard for those certs, and I encourage other people to go out and get the papers so you can be competitive in the job market. So as sysadmins, well, where's my notes? Pardon me. There we go. Okay, so as sysadmins, we have to configure systems, and we spend hours reading friendly manuals, watching YouTube videos, reading quick starts, tutorials. A lot of what we owe our expertise to is the ability to Google better than the next person. So we end up with the responsibility to maintain and configure infrastructure. And keeping track of all that information is difficult. So we have to know which system's doing what are we patching when, how does the patch handle failing over for like high availability systems, what kind of stuff is on-prem and what's in the cloud. How do I join my Linux system onto a Windows domain again? Where's that document? And just how do we keep track of all the things? So we use documentation. And here's a list of effective methods of documentation that I've used. Shout out to all my org mode folks, if there's any of them out there. I've used all of these. You may have your preferred method. And we're still left with some problems though. So our documentation can drift as our systems evolve over time. Where do we put all this documentation so that it's accessible to the team? How do we make the time to document what we're changing? How do we keep track of the changes to our documentation and what that means to systems that are on the old way of doing things versus the new way? Personally, I just can't stand documentation, especially for the sake of documenting. I don't know my audience all the time because of the transient nature of some of the positions that I might be working with. So really the documentation that I like to keep is for future me. And I don't know what future me is going to forget. So I know from the present me that past me was an idiot and did things in a very wonky way. So I like to keep all this documentation in a way that future me will thank me or thank past me and not think that I'm an idiot. So we can use infrastructure as code. We can write all our infrastructure changes in source control and keep track of all of it with Git. So here's a list of different infrastructure as code tools from Wikipedia, and you can see SaltStack's right there in the middle. So using infrastructure as code, you're no longer documenting just for the sake of documentation. You're actually writing code that will influence how your systems are configured and how your application or applications will run on those systems and how they interact with each other. So it's no longer, making configuration changes and just making notes that says, oh, the web server talks to the proxy server talks to the web server this way. It's actually captured in some source control. So SaltStack is the client server technology that runs as root and system on the client, whether you're using Linux or Windows. You can use it to run commands, install software, update software, get information about systems, store information about systems, and you can declare all this in code as granular as you like and get used to the salt puns. So there's more to come. And notice the minions here are calling into the master. And that was one of the real selling points for me because one of the things that I've done for the school system is I actually deployed SaltStack minions to all of our workstations. So, and that's come in real handy here lately because if we're accustomed to getting our policy through on-prem group policy environment, and maybe our Intune environment isn't up to snuff, we can leverage SaltStack to actually deploy configuration changes down to those systems. And no matter where they are, they could be at home calling into the master. So that's worked out really well for us here lately. And you can see there Minion 1 is actually in a cloud somewhere, and it doesn't really matter where it is. As long as it has connectivity out to the master, you can configure it. Somebody else had said in a previous talk that, one of the questions was, well, if I spin up a server somewhere and it has a random IP address, how do I know what that IP address is for the master? And that's kind of the point, is that you don't have to know what that IP address is so the master can reach out to it, because the master won't be reaching out to it. The minion will reach into the master, and then the master will use that persistent connection to talk back to the minion. So really great architecture, in my opinion. So what does that look like in configuring systems in SaltStack? So this is an example of just installing some fictitious package, XYZ. How are we going to install this package? Are we going to use the package manager, the default package manager, or are we going to use some kind of a script? We need to ensure that it's installed, whether or not it's installed, and that's the state. So we have the first part here, we just need to install it. Is it a package manager, or is it some script? We have to create a state. We have to describe where it should be installed. So that's an exciting part. And then we finally deploy it, and then we're done. So that we've deployed the XYZ package. So we'll get into what is a state here in a minute. And then whenever we're deploying, we have to kind of think about, are we deploying to all of our systems? Are we just deploying to a couple of them? How do we target our systems so that we know that we're deploying it to the appropriate one, and then document that we actually did deploy to those systems? Okay. Oh, and then we can track all this stuff as we figure out how to install XYZ and figure out where we're going to install XYZ. We keep track of all of this in a source control. And then using git log, we can see who did what, when. Okay, so we're going to go right into a little lab. Are there any questions so far? Drew is shaking his head no behind the camera, I'm sure. All right. So this is a lab that I put together. You can find it on GitHub. You can follow along. I'm using a Windows machine and VirtualBox and Vagrant. So, and then I had some problems with my Hyper-V set up on Windows 10. I had to turn it off and reboot the system. So hopefully if you're following along, you did that before you jumped on the Zoom. If not, I won't be waiting for you. So you can watch the video later. Okay, so first thing we do is we bring up these systems. So we just go to the lab folder and say Vagrant up, and it'll bring up those three. And that's really boring. I already did that. And I've also SSH'd into each, the Salt Master and our two minions. So the first step is we actually have to install the Salt Master. So in order to do that, there's a bootstrap script that's provided by SaltStack that works really well. But to get that, we need curl. So we'll install curl first, and then we'll download the bootstrap. I'm using the Uber Elite Haxer tool known as copy and paste. And then we'll run the installer script. And in the installer script, we're running with the -m flag, and that's going to install the master. So it's the same script to install the master or the minion. So that's going to get that going. And I'll do the same thing over here. Okay. And, oops, missed that. Yes. Okay. Download that. And then for the minions, the only difference is we don't use the master flag. Okay. Same deal here. Girl. And if you were deploying to like, or if you had systems that were being spun up in a cloud somewhere, or you had some, maybe like Metal as a Service, which is what I use to spin up my on-prem servers, you would actually automate this and that. So this process of bootstrapping SaltStack. So because once it's bootstrapped and Salt is running, it'll call into the master, and then you don't really have to interface with the systems ever again on the front end anyway. All right, so we'll let those installers finish. Should be done pretty soon.
Hey, Nick.
Yeah, go ahead.
Getting one question from the chat. So the question is there a sort of a validation that the Minion has been successfully deployed in this environment? Specifically like logs or a dashboard that show what Minions still have tasks and if there are any failures for any existing tasks. Oh
yeah, we'll get to that. So right now, all that's happening is the Minion service is getting installed and launched on the two Minions, and the master, same deal, is getting installed and launched. So there's a process that runs an agent that runs on each of them, and you can run Salt agent lists. I'll talk about that at the end. But by default, there's an agent that, well, that is interesting. Can everybody hear and see me okay? I just saw like some really weird video quirks.
Seems fine to us.
Okay, good. All right. So yeah, so there's an actual process that's running on the systems, and that's how the Minions are talking back to the master. So there's not a lot. We haven't done anything configuration-wise other than just install this package, but that's what we're going to be doing here in a few minutes. We're going to look at actually deploying some changes. So the first thing we do is we have our environment set up, and there's a little bit of trickery going on. I'll just show you. Cat Etsy hosts on this box, you'll see that there is an actual entry here for Salt, and that is how the Minions know to talk to the master. The master is also a Minion. It doesn't actually need the host entry because its name is Salt. So, but when the Minions actually install Salt, they'll look for any like fully qualified Salt name. So if it's salt dot whatever your domain is of the network that you're on, or you can just do the host entry trick. But if you don't want to do any of that stuff, you can actually add the name of your Salt server in the bootstrap script just by putting in this -a. Okay. So once the Minions are installed and the master is installed, we actually have to accept the keys. So Salt will generate a key pair for each system, and that's how they authenticate. So you actually have to accept it. And this part is actually susceptible to man in the middle. So you should be doing this on a trusted network, or you can out of band kind of validate that the keys are legit. So just something to think about. So to list them, we'll just run salt key on the master. Oh yeah, right, hold on a second. I'm gonna cut a little shortcut for myself because I never type sudo. So I'm just gonna make a bunch of aliases on my bash RC. Oh, dang. That's I'm also going to be doing my development from the master. What am I saying? I want to do sudo apt install. So I need vim, and I also need git. So I'm going to be doing that from here. You wouldn't normally be developing your scripts on the master, but yeah, this is just a demo. All right, so we're going to vim our bash RC. And I'm going to add to these little aliases so I don't ever have to call sudo, and I'll log back in. Okay, so now I can say salt key, and it's going to list out all of my keys. So I've got 2 minions and 1 master. Like I said before, we're done with this guy. The master is a minion as well. So you can configure the master just like you would another minion. So I'm going to add all these. I'm going to just pretend that all this is trusted and I'm not being man in the middle. Salt key dash A to accept all. Do you want to accept them? Yes, I do. So now they're all accepted into the, let's see, salt PKI. So this is where all the keys actually get stored, is in the PKI directory. So they got the masters and the minions. Okay. And just to test everything's working, I'm going to do a salt. I'm going to target all of them, and I'm going to run test.ping.
Hey, Nick, while that sets up, well, it was too fast. I guess that was a challenge. Another thing you're getting over in the chat is there something you would consider the de facto SaltStack Bible, or if someone wanted to learn wanted to learn more about Salt, where would they go?
Yeah, I don't have a really good answer for that. I spent a lot of time on docs.saltstack.com. I think the documentation is pretty good, and maybe Nick Hughes has some input there. I don't know if he wants to jump in or say something in the chat, but yeah, I've just kind of to preface this, I'm a hacker at heart, so like I just kind of get the stuff to the point that it works for me, and I'm like, that's cool. So, and later on, I want to pull up or the puns. I want to show you guys a pull request that actually came in from Nick Hughes, which I think is awesome, and it takes a lot of advantage of a lot of features that are in Salt that I did not leverage before, but I will be leveraging now that I have a point of reference. So that's pretty awesome.
Yeah.
But yeah, Salt is very deep, and a lot of information is available in the docs.
Yeah, to your point, Nick also agrees. So the docs are fine. They're serviceable for learning.
Yeah, and actually there's even tutorials right there on the SaltStack website that you can go through. They cover the surface level things pretty well. Once you get like further into some of the advanced features, I think they start lacking a little bit. So hopefully, those get better over time as this new plugin architecture gets rolled out. So that's going to be awesome. But yeah, there's other advanced concepts that I'll just kind of touch on at the end, just to mention that they exist. Okay, so what can we do now that we have this? I'm sorry, was that all the questions? I guess it was. You went back to mute.
For now, yeah.
Okay, cool. So let's, now that we have the system set up, let's do some interesting stuff. Like I'm just going to target all of them because I don't know what I'm doing right now, right? And I'm going to use the command.run module to run commands on all of the minions at once. And I'm going to run who am I? So they're all going to return as root. So, oh my gosh, what do I have here? I have a system where I can run as root any command that I can think of that'll execute. And if you're into command line food like I am, I mean, you could pretty much just stop right here and say, okay, this is awesome. This is all I need. But we can go further. So yeah, let's just look at like some interesting stuff. What's going on with the listeners? LNPT, let's make that a little bit smaller. So here's our listener setup. You can see that there are no listeners other than SSH running on the 2 minions. And then the master runs on 4505 and 4506. So yeah, so we could just run commands, and I'll just run free just because I feel like it. All right, cool. So errors are fun too in Salt. So we can actually, let's take a look at an error. So I'm going to run rep for the IP address 168.101.10 in Etsy hosts. Nope, I did something wrong. 191, not 101. You can see all 3 of them errored out there. But so here's an example where the 2 minions, they both have a entry. So grep is returning a or a 0 exit code. And then Salt doesn't actually have that entry, so it returns a non-zero exit code, and it shows up as red here. So that's really helpful. At least I found that helpful whenever you're running commands. And if you're just running on a handful of systems, you can just, when everything comes back blue and green, you're like, okay, that's cool, I'm done. It did everything that I wanted it to do. And then if something comes back as non-zero, you'll see it here, and then you can kind of sift through the output. There are other output formatters that I'm not going to talk about, but there's better ways to get access to this data. So you're not just looking at what's there, but it's very helpful. Well thought out, the interface. Okay, so we can run commands. That's great. There is also a concept called grains. So if we look at Minion 1, and I'm just targeting a single minion here. I'm not going to target all of them. Look at grains.items. So Salt is actually collecting a lot of information about all of my hosts. And this is really useful for targeting them later on. Let me scroll up here, right there. So it's got some information here about my CPU. What is it? What is my domain? The IP address of the system, IPv4 and v6, all the hardware interfaces, which can be useful, especially in like 802.1x environments. Let's see what else is in here that's really exciting. There's the OS family information, which I use often. So we can see here, this is a Debian box, distros Debian, the host name. Oh, this is the master, and then it has like the memory. So how much memory is on this thing, how many CPUs are. So this information is really helpful if you want to target like, what's out there in your infrastructure wise. If you just wanted to look at the grains of the system, that'll tell you a little bit of information about your the individual hosts.
This seems like a good point to bring in a question that was just asked. Can you use this for monitoring your infrastructure?
Yeah, sure. So you can actually create custom grains, which I'll talk about. You can look at I guess the IP addresses, or I mean, basically anything that's in a grain, you can actually monitor. The minions themselves, they set their own grains. So you can use it to target them, or you can use it to just check to see like what the values are actually set to. And then there's some other ways that you can actually leverage. You can leverage the state management system to actually set grains based on conditions that are happening. So like we're going to install XYZ, I could actually set a grain and say that XYZ has been installed, right? So that's a helpful way to kind of identify that, like, okay, which systems actually have XYZ installed, and you could just create a grain for that and say app XYZ true. Okay.
And you can also like lean on beacons for real-time monitoring too, right?
Yeah, so there's engines, and can't remember the name is escaping me, but yeah, there's a event bus essentially, that so the minions and the master are all talking to each other. And it's the salt mine, that's the word. That's the one I was thinking of. So yeah, so there's another concept out there that I'll touch on just called the salt mine, where you can actually the minions can actually collect information about themselves, share it with the master, and then that information is made available to all the other minions. So that's really helpful for like real-time information. So if you want to see like, I don't know, just as an example, how many clients do I have on a single server? If you wanted to somehow do some more dynamic balancing based on jobs, you can actually create a salt mine for that data. And then the minions could respond to kind of each other, the data that they were getting from each other, to balance the load. Okay, so that's all. These are all the grains. I can actually just pull grains individually. So just say grains.get, and I'll just say IPv4. So I just want to get the IP address. And now that there's only a little bit of information on the screen, I'll just grab it for all of them. So there's the IP address. I can say like, here's the mem total. So cool. Okay. So, and I've been targeting the minions with just this asterisk and the individual names. This is using something called globbing. So, oh wait, hold on. I'm sorry, I'm getting ahead of myself. Let me back up a second. So I talked about getting grains. Let's set a grain. So I'm gonna say on just the minion. So all the minions, I'm gonna grains set, and it's just a key value. We'll do something simple. So I'm gonna say role is worker. So these two minions are going to get the worker role. So I just actually created a state change. I did not document this, so this is not a great example, but yeah, from the command line here, I can actually set a worker role. And now that it's set, I can actually use it. So I can say grain role equals worker. Oop, and I'll just do test ping. So the two minions actually responded because they had the worker role set and the master did not have that set. So let me move this back over here. All right, so targeting minions, I've been using what's known as globbing, except for that little grain switch. So you can use asterisk, question mark. It's very regex-like, but it's basically shell globbing. So that's why the convention is kind of surround the target in single quotes, so it doesn't mess with your shell. And you can also list them out, comma-separated list of the individual minions. You can use a grain switch, or you can use a subnet, which is useful as well. So if you have a specific subnet where you want to target, you just use the -s. Okay, and then there are compound matchers for more complicated things.
Oh, so, real quick, Nick.
Yeah.
Question just asked, does grains.set persist through restarts?
Yes, it does.
Cool.
So yeah, the minions actually set them in the cache area. So they all store some cache, and that's where the grains actually go. Okay, where were we at? Yeah, so compound matchers. So you can actually notice these are little -L, -G, -S. Those are just arguments. So in a compound matcher, you do the capital G at, that would be a grain, another grain. You could also do an L. So, and then this is the globbing. So I would say this is, I want the grain of role equals worker. I want English family is Debian, and I don't want anybody that ends in Fred. So that's an example of a compound matcher. So that tells us, well, we know about this. We know about whether or not XYZ is in package manager, and we know how to create shell scripts. What about this state thing? How do we know what is a state, right? So state is really two things. It's a check to ensure that the system has whatever you want it to have. And secondly, it has a state can actually take a system from its current point into a point where it actually makes the changes for whatever you want. So in this case, if we want to install something, then it would say we would have installed as the state. So it's a past tense verb. So if it's not there, it will be installed, and it's also checking to see that it is installed. So the way that we actually deploy states is using salt state files. SLS is the extension. And here are two salt state files. We have using the package manager. If there was a package called XYZ, we would just call package installed. And this is an abstraction that leverages the operating system's built-in package manager. So in Debian, that would be apt-get. And if we were in CentOS, it would be yum. There's even package managers for Windows. I think there's probably one for Choco, which is really cool. So anyway, and otherwise, what I'm accustomed to doing is, like, if I have something that's a little more complicated, or there's not just a package in the package repo for my operating system, I just use a installer script. So, and notice the script is actually called installed. It's not installer. So it's a special kind of a special script that if the package is already installed, it won't actually do anything. Just checks to see that it is there. Okay, so we're gonna do some of this, and we are gonna keep track of what we do by using Git. So let's go to where our salt file server actually is, which is by default in the SRV folder. So I'm gonna go ahead and copy this over. Again, using the Uber Elite Haxer tool, copy paste. Yep. That's my name. That's my email. Everybody knows that I'm the one making changes. And then I'll just edit this folder. Oops. Who am I? I'm Vagrant. This guy. Okay, that's better. All right. So first, actually, I'm going to cheat a little bit. I'm going to pull down the GitHub repo. So this repo here, we're going to copy this guy, and we're going to pull it down here. Because sysadmins are lazy. All right. So let's, as our first example, let's install screen fetch. So I'm on the master right now. I'll just run screen fetch and we see it's not there. So I'm going to copy from SaltTalk SRV. Yeah. Salt. And so we have screen fetch the folder. I'm taking this out of source control. Oh my gosh, what's happening? P-R. I don't have my split keyboard at home. I really miss it. SaltTalk SRV, salt, screen fetch. We're going to copy this over to SRV. Oh, I have to make the folder salt. Oh, man. Okay. Here. Okay. SRV, salt. Okay, there we go. Yay. All right. Oh, I just messed that up. SRV. And we're going to move screen fetch into salt. Okay, move screen fetch into salt. All right, all that work just to see that SRV salt, screen fetch. All right, here we go. So there's our installed package. So it's very ugly. Echo. Okay, so screen fetch is just using package installed. So screen fetch is in the package manager on Debian, and we can deploy this. I'll just deploy it to the master here. State.sls screen fetch. I'm not even going to bother typing. Boop boop dot installed. So I'm calling really this path, right? Screen fetch and then installed the state file. So that's what I'm actually calling here. So it's going to run this state file. It should come back here pretty quickly. It's probably taking a second to do a apt-get update. Okay, so we have it succeeded and we have one change. And the change is that all the dependencies are satisfied because that's what the package manager does for us. And if we run screen fetch now, there we go. Yay, screen fetch is working. Hooray, exciting. So we just tested it. It seems to work. And we're going to go ahead and look at what's changed. So we have some untracked files in salt. Add, git, commit, and add screen fetch. Install. Okay. So there we go. We have one change. So we're keeping track of what's happened, right? So we're just using git to do that. And that's the infrastructure as code part. It's magical, right? Okay, so now that we actually know how to install screen fetch, the next part of our example.
Hey, Nick, before you move on.
Yeah, go ahead.
Just a quick question. You don't have to have the repo on the master, right? You can just point your salt master to like a remote git repo.
Oh yeah, so the way I do that is it just pulls it down. So like it'll just do a git pull, and then so yeah, I'm actually making, like in production, I'd be making changes like on my workstation and testing them in a test environment, and then whenever they're ready to go, the master will pull them. Well, the salt master will pull them down from the git's master branch, and then they'll actually be in production. So that's the idea. But like I said at the beginning, you wouldn't want to make your changes in the production master. You can actually feel free to spin up this this little 3-node Debian environment and make all your changes there, and then send your source code up into an actual repo where you're keeping track of all this stuff.
Cool, thanks.
Mm-hmm. Yes, make all the changes in production. Thank you, Nick. Okay. So yeah, so this last part here is we're going to describe where XYZ should be installed. So we have our state file, it's working, but how do we describe where it's going to be installed? And for that, there is a top file. So we're just going to make this file. So I'm going to bin this guy, and it starts with base. There's other environments that you can apply here. So you can say dev test, but base is the by default the production one. And so I'm going to say the screen fetch should be installed on just the minions as an example. So minion, oops, I'm in replace mode. How'd that happen? Get out of that. Insert mode. Oh. Minion. And I'll do the question mark. So Minion question mark. And what are we going to do? We're going to screen fetch dot installed. Okay. So now that I have my top file, I can actually leverage it to deploy the state, the last part here. So I've actually described where I want XYZ installed, which is just on the 2 minions. But this last part here. So this is what's called the high state, but they changed the name. Salt had changed the name just to be a little bit more clear, I guess, just to state.apply. We're going to apply whatever the state is. So, and for now, I'm going to say I'm going to apply the state to all of the minions, just so we can see an example of a failure, right? So the first one has failed. So Salt says, oh, you know, you asked me to apply my high state, but I looked in the top file and I didn't find anything for me. So that's our first error. So, and that's just because our top file doesn't have anything in it for Salt. So one of the things that some people do is they'll put something in the top file that just applies to everything and it's kind of benign, just so that that error doesn't occur, because you should always be able to call a high state. You don't want the high states to actually throw errors. So, because the minions can actually, they can call their own high state as well. So, but right now what we're doing is from the master, we're actually telling the minions to go deploy a high, or go run a high state and actually do everything that's in the top file. So here, minion 2 installed screen fetch like we expect, minion 1 installed screen fetch. So we have 2 changes. If we run the high state again, it's going to look a little different because we already, everything worked. So we're not going to have all this huge list of dependencies that have changed. So we were able to call the high state again, and it says that it's already installed, and it's already installed there. So they succeeded, and we didn't have anything change on that second run. So, and just to test it out there, we'll say screen fetch, fetch, yay. So there we go, minion 1, and what the hell, we'll do minion 2 as well. Oh, that's great, fantastic. All right, we're done for the day, right? We're getting paid this week. Okay, so let's look at a more complicated example. Let's install Go. So I'm just going to copy from source again. Copy -r, salt talk, srv, salt, go. So I'm going to copy that whole folder to srv salt. So we're going to move Go into the production. So srv salt, go. What does that look like? It's 2 files here. We have our state file, which is running a script. And the script is coming from, oh my, what's this? It's salt : / go install.shell, which is this file right here. So this is really cool. All the minions actually have access to a file system that is living on the Salt master. So we're working within the Salt file system now. That's what this directory is, everything that's in here. So all minions actually have access to every file that's stored in this directory. And you can change this if you want to. You can also source it from other places like Git. But yeah, so this is pretty cool. So we don't have to deploy this installer shell script to all of our systems. It's already done for us through the Salt file system. So let's go ahead and deploy this state. Well, actually, no, I'm sorry. Got to keep me honest here. I'm going to commit this change, right? Git status. I actually have a few things to commit behind. So we're going to git add salt top and git commit. What do? We deployed screen fetch. Okay, and then, so now we just have the git status. Now we just have the Go file. So we're going to git add everything, commit, add, go, install. All right, cool. So let's, ideally, you know, we would have tested it out before you commit it. So let's test it out now. I'm gonna deploy just a minion 1 because I do want to save something for later. Salt minion 1. What am I gonna do? I'm gonna state.sls go.installed. So we're gonna test it, make sure it works. And this is going to take a minute because it has to download it from Google, and should be fine. So it's downloading. Oh, I didn't actually show you guys what that looked like. Here, let me drag this over. There you go. Here's what the installer shell script looks like. So we actually have a check here at the beginning where it's just going to check to see, does the Go binary actually live on this system? If it does not, then it's going to download from google.com the Go version 114. I think 0.1 just came out. And we're going to extract that to user local. And then we're just going to delete the tarball. So that's what this installer script is, or this part of the script is doing. The second part here is we're actually adding the path to the global profile. So again, we have a check that actually says, does Go bin actually exist in Etsy profile? If it does not, then we're going to go ahead and add it to the bottom of Etsy profile. So that's what this installed shell script does. It's not that different from what you would do for an installer shell script. You're just kind of wrapping some checks around it so that when you redeploy it, it doesn't actually reinstall Go. It's just checking to see, oh, Go exists. I can just skip over this part. Okay, the profile exists. I can skip over that part too. So that's the idea. Okay, so we have this script actually ran and it succeeded, and we had one change. And it ran for 17 seconds. So we're going to run it again just for fun. And you can see the second time it came back and said, yeah, there was another change because we're not actually deploying one of the higher level, magical things of Salt. We're actually just running a shell script. So it's going to run this script every time. So it did run. It had a process ID, and it just went away in 69 milliseconds. And that's because we know from this script, when it ran that second time, all it did was check to make sure this exists and that this exists in this file. And once this succeeded and that succeeded, it went on and it did nothing. So that was kind of what the shell script actually accomplished. And we did this on Minion 1. So let's go to Minion 1. And right now, that's not going to work because we got to reload our profile. And I got to spell it right. There we go. So now we have Go installed on Minion 1. That was exciting. Okay. Where are we at? Go installed. Yep, that worked. Cool. Oh yeah, so we want to deploy it now. So again, we're going to go ahead and modify our top file on the master. Oh, this thing is in my way. Go away. Okay. All right, cool. Where am I at? Salt. Okay, bin top. So what I do, I said I'm going to install this on Minion 1. One is going to get the state go.installed. And again, we'll call the high state. Nothing will change. Somewhere in here. Okay. So again, we have nothing for our master, so it throws an error, and then this guy works. Let's fix that error. Just target everything. Oh my gosh. How did I end up in replace mode again? Yeah, everything. Everything. There we go. I made 2 changes. Don't tell anybody. My commit message is going to be inaccurate. So let's go ahead and apply that. All right, cool. So everything ran and no errors were returned. So let's see. Now, yeah, you can see here that the top file has 2 changes in it. Oh no. Deploy, go. Nothing else. Oh, all right, moving on. I hope you guys are laughing on the other side. Or this is bad jokes. I mean, these are the jokes, sorry. All right, so let's look at a more complicated one. That was cool. We deployed Go, simple shell script. We're gonna do one more. Let's do net data. Net data is a fun tool for looking at all the stats. If you like pretty dashboards, net data is a tool for you. So I'm gonna copy again, because I'm lazy, from my Salt repo that I have. Copy R, and where are we at? SRV. Oh no, sorry, backwards. Salt talk, SRV, salt. And what are we doing? Net data to SRV salt. All right. SRV salt, and look at net data. And so this has 3 files in it. So we have a installed state, which is what we plan on using to actually install this thing. And it's going to do something similar. It's going to run a script, which is our installed shell script. And then here we have this include netdata.deps. So this is this deps state. So we're going to include a state in a state file. So let's look at what that is. So these are all the dependencies. And the way I did this was I just did that cool little thing in your editor where you can make your cursor tall. And then I just hit enter a few times and typed out : enter space pkg installed. So it was really easy. And then I just saved the file. And so now I have all the, oh, I'm sorry. And how did I get these dependencies? In testing, I actually ran the netdata kickstart, which is install.shell. So I ran this file. This is the way that netdata tells you to install their software. And this is one of those scary things that you do where you grab a file from the internet and just pipe it right into bash as root. So awesome. Good times. Like I said, I am a hacker, so deal with it. But yeah, so what am I going to do? I'm going to check to see if netdata is there. If it's not there, I'm going to go ahead and run this thing. And when I ran this thing in testing before, it showed that, oh, there's all these dependencies that you have to take care of. And you can see here from the dependencies that we're actually compiling this thing on the fly as we do the installation. So cool. And that's a result. I'm going to status again. Commit. Data. All right, I keep wanting to say git push, but I don't actually have a remote repo. Okay, so the deps are there. Let's go ahead and deploy this thing. Again, I did it backwards. You should always test before you do this. So I'm gonna again do this on Minion 1. This is gonna take a minute. State.sls, and this is netdata.installed. All right, so that's deploying. Actually, let's do some fun stuff here. So you can see here, it's doing these apt-get. Still doing apt-get. Yeah, we don't really see anything happening until it's all done, and then you'll see it. Oh, something I forgot to mention is that whenever you actually run something, like if you run an execution module right here in the command prompt, it'll actually run in parallel. So if you target like all your minions, and like at the school system, I have thousands of minions. I can target them all at the same time. And they'll all start responding in parallel. So I'll start getting responses back as the minions finish and send their data back. That can be good and bad, depending on what you're doing. You can actually overload the bus. So there's some fun little, I guess, I don't know, I wouldn't call them tuning, but you can just leverage some utilities that are built into this Salt. Like you can batch the jobs up. So it's just -B and then a number. So I've been lately I've been deploying software to like all of the school system workstations in a short order. So I just batch it and say, okay, 30 at a time are going to be sending it back. And that's just to make sure that I don't overload the bus. Okay. All right, well, that's happening. What else is there? Let me pull this over. Okay. Oh, we're going to jump right into pillars. Okay. Hopefully this finishes soon. Dead air. Any questions? Comments? Concerns?
Not in the chat room for the moment.
All right, cool. Hey, look, some people are typing LOL and ha ha ha. Good.
We totally get the jokes.
Okay, good. Well, hopefully that Kickstart script still works. I did not test that today. Let's see. Let's see what else is happening over here.
Would you be able
look at that. Make is running. Hooray.
Would you be able to tail the logs on the Minion? Is the verbosity set?
Yeah, that's a good question. Let's see here. It's going to be it's just going to be syslog, I think, by default. So tail. Yeah, I got to be that guy. Who is this? Our oot fellow. Oh, that's just the package install. Are we done? No, we're not done yet.
It's probably var log salt Minion.
Oh yeah, okay. Sorry. There we go. Nope.
Yeah, the verbosity.
Verbosity is low. Yep. All right. Let's see here. I wonder if there's like some crypto happening, because this happened a lot quicker on my my Mac laptop. All right, we'll just let that keep going. I could quit out of this, by the way, and it will actually run it as a background job. Dare I do that? Let's go ahead and do that. There we go. So now there is a background job, and it's going to keep going until it finishes. So I'm not going to see the output of that. I can actually pull this up later and see the output. So let's just make note of that. Put it in my clipboard. What is a good GUI to make the Minion statuses more presentable? I do not know. Nick Hughes, do you have any ideas for a GUI? Putting you on the spot. Oh, you know what? He's muted. Maybe you can type something.
I can say that's one of the paid products for Salt. Is their Salt Enterprise comes with a really slick GUI and a ton of additional management features. I'm trying to see. Just wondering if Nick has anything to say. Yeah, just echoing. SaltStack Enterprise is worth it.
Okay, cool. Yeah, I do not actually. We don't pay for Enterprise in the school system. All right. Probably, nope, still not done. GCC, oh my gosh. Oh, I'm sorry. Oh, it's taking a long time. All right, let's move on, and we'll come back to that job ID. Let me make sure that I save that. Yeah. All right. So, pillars. All right. Let's see. So we've been deploying state files, which do not really have any data in them per se. So they're just deploying kind of built-in stuff, packages right now, but we could also do things like generate keys, key pairs, really anything you can think of. But it gets complicated whenever you're dealing with state files, and let's say you want them to be a little bit more dynamic. Maybe you want them to iterate over some data. And if that's the case, you wanted to take advantage of something known as a pillar. And a pillar is similar to, well, the way that pillars are deployed is kind of similar, where you actually have an SRV pillar and a top file, which is very similar to the top file in the Salt file store. But the biggest difference between the Salt state deployment or the Salt file deployment is that the minions don't automatically have access to the pillar data. So this is a good place to keep sensitive information. You can put secrets in here, but you're going to ideally commit all this stuff. So maybe you want to manage your secrets elsewhere. But yeah, it can kind of be used for secrets too. So here's an example, and I'm not gonna load through this just because we're a little after 8 right now. But yeah, so the idea is that they're going to actually take all this pillar data, so which is just a user name and a user ID, and then you can actually use the more complicated stuff here. So this is some Python. This is Jinja, right? So Jinja template. So we actually have an accompanying. Here's the pillar data. So it's a pillar top. We're going to deploy the user's state or the user's data. So this is the SRV users state, which is our data, and it has this data structure. So, and then in the Salt state file, we actually have users init.sls. So we would be deploying users.init. And then when users init deploys, it'll actually loop through all the data that's stored in the pillar. So it's going to pull this data, and it's going to set the user and user ID variables. And then it's going to spit the user name right here, followed by a colon, user.present, user. So this section here looks a lot like what the actual state file would be. but it's just iterating through the data so that you don't have to modify the state file. You can go back and modify the data. And then when you redeploy, it's going to expand it out and it becomes this. So we see Nick, user present, and the user ID is 30,001. Tim, Jen. Yeah, go ahead.
Look, some people are curious, what exactly is Jinja in this situation?
Yeah, so Jinja is a templating engine. Let's see here. Jinja. Jinja 2. So let's just go here. So it's a templating engine. It's really useful, but here's the documentation for it. But yeah, it's modeled after Django's templates. But it's a nice little language that you can use to take what would be like a text file. So here's an example where it's actually just taking some HTML and then it's expanding out this list. It's an unsorted list. So, and it's going through, it's a similar example where we're going for users in, or user in users, the user's array, I guess it would be, or list. And then it's going to expand it out and do this. So it's a templating engine. It's not, it's not just for Salt, it's used for all kinds of stuff. So yeah, it's a fun thing to learn. Okay. Oh, now let's take a look. Where are we at with this thing? It's probably done. Yeah, it looks like it's done. Let's take a look at our job ID. There we go. Look at all that. So that's everything that we were waiting for it to do, to come back and actually run the installer and compile the software. And now we have net data deployed to Minion 1. And actually, if we look at LMPT, oh, yeah, right. Let's just SS. Memory here. So we have, that's the port. That's what I was looking for. So if we look at this port, I'll just show you what net data is if you don't know. 127.0.0.1. This guy on Minion 1. And I get a browser. Kingdom for a browser. All right. Local host. This guy. There you go. There's net data running on Minion 1. Ooh, amazing. Look at all these fancy graphs and junk. So I've used net data just to like I ran it on a Raspberry Pi once so that it would send some status information back to a centralized net data server that just tells whether or not it would just load this one page over and over again. And then I would get this fancy graph that tells me what was the actual time that it took to run the page. So I took that Raspberry Pi and brought it out to a school and set it in a room somewhere where somebody was complaining a lot about this page not working. And then I had the data to go along and said, look, everything's working fine. Must be you. So yeah, net data is cool. Anyway, and we just deployed it with Salt. So we can take that same state file and we can deploy it to all of our minions, and then all of our minions could have this pretty dashboard. So anyway, hooray. Infrastructure is code. It's magic stuff. All right, let me pull up this thing here. I'm gonna pull up the summary, and then we're gonna do something else. So so SRV Salt tells us what is deployed how. The top file tells us where these states are deployed. Git tells us who did what when. The pillars are great for kind of secret data, but more for like complicated Jinja stuff. And then finally, the top data tells us where the actual data goes. So before we jump into the end, the extra bits, when this was announced, oh, I'm on the wrong one. I won't mind. There we go. Hold on a second. It's right here. Okay. When we announced that we're going to be doing the Salt Talk, Nick was actually nice enough to propose some efficiencies to the talk and the actual files that we're using in this demo. Nick, do you want to take over for a minute and talk about these efficiencies?
Sure. So how do you want to do it? You want to look at the files changed?
Sure. Well, we can just do like a comparison for, let me see here. There we go. Files changed. There we go. So here, I'll just kind of give my interpretation. You can add and subtract from that as you see fit.
Sure.
Yeah, so like I said at the beginning, I'm a hacker, so I know like this installer script will work. But there are all kinds of awesome little salty stuff that you can use
Hey, Nick,
to do the same thing. Yeah, go ahead.
can you make the browser text a little bigger?
Oh yeah, sure. Sorry. There we go, and I'll make it wider too. There we go. Is that better?
Way better. Yeah, thanks.
All right, cool. So yeah, so we're just taking this installed shell script, and then we're doing pretty much the same thing, but this is all salt stuff, right?
Yeah, definitely. So, the main thing is that salt wants to be idempotent, right? It wants to run multiple times and, determine whether or not it has to make changes. So, when Nick was going over this particular state, he ran it a couple of times and it came back faster, but it said that there was changes each time. What's going on in the background is that on the left-hand side, Salt is only concerned with running the script, right? The script was written in an idempotent way where it checks to see if it was installed first before proceeding. But Salt has no knowledge of that, right? It just said, yeah, I ran the script. There was a change because I ran the script. I did a thing. So on the right, we've basically transitioned to using more of a salty method, if you'd like to put it that way, where we're using native salt states that do the things that are inside of that shell script. So at a real high level, what it's doing is that it's checking to see if it's installed, right? It's extracting the tarball, and then it's dropping the go path inside of your system path so that you can access it inside of the shell script. So on the right, what we're doing is that same thing, but using salt native methods in order to do it. So for instance, we're using the archive.extracted state in order to extract the tarball onto the system. The name field is where it's going to be extracted. So that tarball is going to be extracted into user local. The source, notice that we have the website location instead of a local location after we download the tarball. So Salt's archive.extracted state has the native ability to go to a website and download things for you, so you don't have to manage that. Skip verify is basically because I'm lazy and I don't want to type in the hash of the source tarball, but that's what a normal secure installation would look like. You would find the hash so that if maybe the tarball was corrupted in transit on download, or somebody was being nefarious and replaced your precious tarball with something bad, you would be able to tell that because you have that hash saved. Archive format, you're telling it it's tar. Options, you're passing in Z because it's an option to tar that tells it that it's gzipped. Enforce top level is something that you have to do to some tarballs based upon how they're formatted. It's hard to say, but generally Salt expects there to be one single directory at the top of the tarball. And so if there's like a README and then a subdirectory or something like that, that it freaks out. So enforcing top level basically says, I don't care if there's a tar bomb in there with billions of files at the top level, or if it's just a single directory like I would expect, I'm going to extract it no matter what. Fail hard tells it to fail if there's an issue without going on to anything farther down within the YAML file. And overwrite's going to overwrite the files in place if it does in fact determine if something needs to be done. So archive.extracted will check in the unless requisite, which is below there, what version we're running. And if that returns where it's not equal, or if Go isn't installed and the command fails altogether, it's going to go ahead and re-download and try and redeploy. So Salt's taking care of all of this stuff in the background, and we just have to consult the documentation and determine whether or not we can use certain options in order to accomplish our goals. and then utilize those instead of writing a shell script to handle it for us, right? Sort of abstracting away a lot of the details that we have to manage ourselves when we do a shell script.
That's awesome. Thank you very much for that, Nick. This is really cool. And in summation, I just take my takeaway from this is maybe I'll be a little less lazy, right? So I also like the packages. I did not know that, but you can actually just give it a list of packages. So
yeah, the important thing here is that if you were to run the one on the left, in the background, what's happening is on a particular system, the package manager is running for each iteration of this. So it's saying, if it's Debian system apt, hey, I want autogen, I want automake. It's almost like if you had to type each of those commands separately, right? Like apt install automake, enter. Apt install cmake, enter. Packages allows you to specify a list so that it's thrown into one, the equivalent of one CLI session. So it's much faster, right? It doesn't have to execute each one of those commands. It does it as though it's all on one line.
and this is on that net data that we were just waiting forever for. So cool.
Yeah. So if you load the diff of the, oh, that's the.
Yeah, that's the net data.
Yeah. Okay.
Takes
So
care.
this one, basically, we're still using command.script to run the netdata install script, but instead of having to download it and source it from the salt file system, we're sourcing the kickstart script directly from the web like we are with archive.extracted. We're passing in arguments via command.script, and then we're telling the command.script state that it creates a file called user sbin netdata. And if that user sbin netdata file happens to be there, then it considers its job done, right? So if I were to run this on subsequent iterations, instead of getting changed over and over again, for the command.script, what it's going to do is to say, oh, well, user sbin netdata is already there. I must have already run successfully. I'm not going to do anything, no changes. And that's how you get salt states to run clean, right? So if I run this 7 times, the first time it's going to do its job, and the subsequent 6, it's going to say no changes each time, nothing's going to happen. And that's how you know your systems are in spec, right? When they come back and there's no changes.
Very cool. Yeah, that's awesome. I will definitely be using that. So, and just to show everybody that it works, I'm gonna merge this in because it's awesome. And oh, it's at the bottom. I gotta hold on a second. I gotta do this. I'm losing my mind here. It's too big. Yay, confirm. So rather than talking about some fictitious person that is actually making changes to our infrastructure, here we have an actual person that did some cool stuff for us. There we go. There's our changes. And we're going to rsync. I'll just do the go one for now. Rsync salt go. And that's going to be replaced with this, salt go. All right. Yeah. With the correct switches. Okay. That was just that one file. And then I'm going to vim. And we're going to install Go. We're not going to do this one anymore. Let's install Go on both of them. So this is going to do the same thing, only way more efficiently on Minion 2, which does not have Go on it. The law offices of Nick and Nick. Nice. How will upgrades happen if it stops when finds the directory? Oh, something broke. This is probably just my crappy overloaded vagrant environment. These poor little boxes have very little memory, so just 500 megs. Show the go install file. Sure. So SRV, make this big again. Salt, go. There you go. That's what's happening right now. All right. Oh, I just destroyed everything. Fantastic. Let's see if it worked. Nope. What is going on here? Well, you know, I guess we can't get away from the presentation guides. No, I just want to do a test ping.
It happens to the best of us.
Yeah. Apply your state, damn it. And then, you know, my experience with this is it does happen sometimes where like we just lose connections. I'm gonna blame. Let's see, what do I want to blame today? I'm gonna blame VirtualBox on this one. That's what I'm gonna blame. Yeah, it's definitely not my fault. All right, we're gonna have a blameless postmortem after, and we'll actually get to the bottom and see how we can improve this going forward, because we are DevOps. I do not know why this isn't working. That's cool. All right, so let me go back to my presentation. We'll just ignore that. Take it on faith that that thing works. So there you are. Okay, so some of the extra bits that I kind of touched on. Docs.saltstack.com is a great resource. Python, YAML, and Jinja are our friends in, you know, actually creating state files and doing fancy things with them. Salt SSH does exist. It's a clientless way to do SaltStack, so you can actually like run SaltStack on some really amazingly small things. Like if you had SSH access to a switch, that's good enough to run salt states on it. The salt mine is a way that you can actually think of it like grains, but on steroids, where the minions can actually make data available to other minions through the master. So it's a really great way to coordinate information. So like as an example, let's say you had to create like a mesh of like a full mesh WireGuard VPN environment, and each minion had to share its public key. So you could create a mine that just gives all the minions access to get all the other minions public key. So, and then a runner is they're convenient programs that you can actually run from the master. I don't really use them a lot, but one of them that I was looking at in the docs as I was making this presentation was the DRAC. There's actually a runner for the Dell remote access card, which I use Dells at work, and that's something I'll be looking into. So anyway, I'm ready, you know, available for questions, and thanks for your time and coming out, and go forth in DevOps, and don't forget to have fun while you're doing it. I'm imagining there's clapping happening on your side, so that's great. There it is.